will we will see the stack definition and how the stack works. And after we will go through the algorithm of the stack. Then we will have some examples on the stack. So this is the first session for the stacks. So let's begin. So stack is an a stack is a linear data structure. Okay, everybody know that it is a sequential order. So we perform the push and pop in sequential order. So the runs on the first in first out. Whenever we push an element into a stack, the first element will goes last. So it's a kind of a plate. So when we have a the plate above the plate, so whatever the plate we keep first, so that can be taken out in the last. So same principle on the stack. So we here we have two operations. We perform the push and pop operations. The push and pop operations, uh, these two operations has a time complexity of O of 1. So mostly, so insertion is a big O notation of 1 as deletion. Accessing any element in the stack, it takes O of n. So so it it performs a deletion at from one end only. So as I said, right, it's a FIFO. So first in last out, you cannot take element, we cannot take out the last plate from uh, the list of plates. I mean, whatever we keep one above the above plates, right, we cannot take the last plate out. So that's all. So let's go with an example. So let me take you to the example. So here we are performing an push operations. See, I want to push an element into an stack. So first my stack will be empty. So whatever the size I have declared here, it is a 3. I mean, so here I'm pushing the element into a stack. I pushed the 10 element. So later I'm pushing the element 3. So element 3 was pushed and 10 went down. See, the top of the element is 3, and I have, sorry, so again I have pushed the 40. So the 40 element is in the top of the element, and you can see the below the 40 you have 30 and 10. So similar way, this is a push operation. So we can push our elements into an stack within a very faster time. This is a O of big O of 1, it is on time complexity. So yeah, when we go with an pop operations, so if we see the pop operations, the current stack is something 10, 20 and 30 is a current stack. So top of element, the current stack is 30. When I was trying to remove the element, when I was trying to remove the element from the popping out, so that's a removing of element from the stack is called pop. So we are popping out the element, the top element will be popped out. So 20 is popped out, you have with the leftover with 10. So same way we have. So give me a second. Yeah. Again, so this is a simple push and pop operations of the stack. So we will go with an algorithm. So just we will implement we can implement the stack algorithm using arrays or the linked list. So just we will implement using an I will take you through code as well. We will implement a stack using Java. I mean, we will implement the stack in the Java using array list, and we will be go through the code as well. So just for focusing on this, first we will initialize some element as a -1, and we have an array element. When we push any element, we will have an array increment. So where t is an index, so we are incrementing the tree and assigning that variable. Whenever popping out, just we are decrementing that index. So and we are removing that element as well. Here top top, it represents a peak, and top represents the top of the element. Whatever the stack we have, the top element is a, so here again we have a size is nothing but a t. So here we are starting with -t, so we will have a +1. So that is the size of an stack, whatever we use a stack, right? So if we have 5 elements, the size will be 5. Okay. uh, so here we will go through the uh, given a, so let's take in some problem to solve on the stack. Given a list of integers 10, 20, and 30 and calculate the average. So simply we will what we do, simply we store the sum in the top of the stack. Like so whenever we reach an element, so let's start. I'm pushing it to an stack. So what I do when I push into the stack, right, the 10 will push into the stack. Okay, 10 on the top. So when next element comes, like 20 comes, so 20 comes, it directly performs in sum operation. So 20 plus top, it is almost 30. So 30, 20 plus uh, 10 plus 20 was the top, previous top plus 10, 20. As the current element is 20, then it is push operation. So it will store the sum elements. While we do pop operation, right, we'll subtract. So for example, I'm popping out 40. Like, so first I have pushed 10, next I have pushed 20, the sum is 30, and again I push 30, it is 60, and if I push again 100, so 100. After 100, if I perform a pop operation, like pop of 40, if I perform pop of 40, so 100 minus 40, 100 minus 40, it will be a 60. So popping of 40. So we get a sum, we hold a stem using an average in a stack. So simple stack, we can perform the average calculation. So average is just top, or top element, it returns top, will return the top element by size. By size is how many elements we have, like 4 we have. So by 4, the whatever average we get calculated. We see the example complete implementation with C. So what we are going to implement is, we are going to implement a stack using Java. So we will implement complete stack, and we perform the push operation and pop operation. After that we perform the peak, uh, try to get a min element. Let's assume I have a 5, and what is the minimum element in the top 5, and get from this list, right, whatever stack we have, try to get the minimum element and the maximum element from the stack. So if you have like 10, 20, 30, 40, the maximum element will be 40 and minimum element will be 10. So when we perform a in min get min, it will return you a 10 element. So like that we perform sum. Like if you have a we have, let's assume we have 5, 1, 10, 20, 30. So in single operation we can get it as sum as 100. If you delete it, if you're deleting the top element, right, so sum will be returned as 60. So 40 will be deleted and the rest amount will be 60. So similarly average, we perform some by size, it's an average. So we will going to implement everything uh, in this coding. Let's go ahead and do the coding. um, so I'm using an Eclipse. I mean, this is an Eclipse. So just let me go ahead and create a class for us. Okay. Just we keep it as stack IMPL. Just implement a stack Java. Okay, that's good. So let me first we plan to implement the push operation. We need a push method, and after that we need a pop operation for popping out. And next we want, if we want to get the top of element, right, get top operation, the returning of top element, and get min operation. So what is the minimum element in the stack? Okay, and get max element, max element max element in the stack. So we need one, and also we want to perform the sum operation. Okay. And we want to perform get average, average uh, average of the elements, like stack elements, whatever stack element we want to. So sum operation on the stack elements, push operation on the stack. push operation on the stack, and top operation on the stack, min operation to get a min element from stack, uh, max element from stack, and sum of get sum of elements, sum from the sum of elements, okay, to get a sum of elements that is from the stack itself. Okay, so let's go ahead, write a method. So I'm writing in a public so void. If we go with the push operation, it is a void, push, and we will pass some element to it. So that is, so if we are passing some element, that will be, let's assume that is an integer, okay, integer element, let's assume it's an element. So if nothing returns, so if we check that if, so before going to this, we need to create an array list. The stack, uh, so we'll import it. Okay, so we need one more element, that is index, and also we need to maintain a array of some right in a single operation. If you want to get a, so we array array list of some, okay. And if we want try to get a min, array list of min, and array list of max. We are performing all the operations. So we have a public, this is a push method, push operation. Next we have pop operation. Public, it returns, pop operation will return element, so we will return integer pop, no params, being we return null. So public, so try to get the top, so integer, so integer, perform the top operation, that will return the top of the element, return. So just we can say stack index is the top, and being the list of index, or we can perform dot get. This returns the, if you want to size, this is the top, top of incorporation on this size of stack, simply written public size humanity, and just simply start the index with -1. Public. We want to perform the next method is next method we want to do is get min operation and get min operation. Okay, just simple min returns an integer. Return as null. Public get max. This will return integers. Integer. Return null. And next we try to perform the sum of elements in the stack. So public formula elements will be a double. So let's sum will take it. Return return null. Okay. Select. So again we have average. Calculate the average. Average. Calculate the average of sum, that is public. So if we calculate the average, sorry, it will not be double, it will be integer. And if we calculate, it may goes to double. So we say double average. Simply we do. So we will return it as null. Null. Okay. So okay, let's implement the push. So these are the methods we were going to perform on the stack implementation. So we implement a stack using an array list. So we have a array list. We are using three different arrays stacks to maintain the sum at some point of time. And if you remove some element at point, what is the sum? So similarly, min and max also we are maintaining and calculating the sum and average in a big O of one time complexity. So this is let's implement this tag elements. Give me a second. Okay. Um, so let's implement this tag. So if element is passed, let's assume. If the stack is empty, we will add the element directly. So we will push the element into an array list. So our array list is already created. So let's name it as array list. Okay. Stack, whatever we name it, stack or list stack. You can say it as a stack itself. Let it be stack. So just what I have to do, stack dot add the element. Okay, add the element. So we will add this element. Okay. So this is a pushing, just we pushed our element and just we are implementing the index. Okay, we have implemented the index. So similarly, if you want to pop the operation, right? If you want to pop the operation, you have to check the to check the top should be empty. So get top, it should not be empty. I mean, stack should not be. So we write something like this: stack, stack is empty, question mark, we return -1, uh, colon, we return else, we return stack dot get index. Okay, so whatever we have index, we will return that element. If it is a, if it is, so if we have any elements, it will return, it will delete, it will return that index, and we try to delete it. So okay, sorry, here we cannot perform this operation. Okay, what we do, just simply take return some integer. Okay. Just copy paste this. Okay. um, After copy paste, what is the error that we see? Okay, return res equals to, so we got some res and we return this res, and we have to decrement the index, right? Okay, we have to decrement the index. So this is a simple stack push and pop operations. Okay. Mm. Okay, so let's implement. Okay, so just we will try to see that our push and pop are working or not perfectly. So just what I will do, I will create an instance. My instance is stack impl, stack impl st, okay, equals to stack. Okay, so just I perform stack dot push, then stack dot push 20, stack dot push 40, stack dot push 40. I have pushed the 4 elements, and again I am just uh, let's implement the toString method also. ToString, just implement the toString method. So what we do is we will print the stack. That's will be fine. So after the implementation, right, if you want to print the stack, just what we do, array is stack, whatever stack we have, stack.
It's 9 o'clock.
ToString. Okay. So system dot out dot println. Okay. Println. We call it as stack dot toString. So this will print the list of elements. Later we perform the stack dot pop operation. So stack dot pop, perform the 2 pops. Then again we let's display the stack again. Okay. Stack, okay, contains stack. Stack contains. Let's run this. If you see, we are trying to push. So if you see, we are trying to push. Something went wrong. We are unable to perform the pop operation. Oh, sorry, we missed something. So after the popping out, remove the index. Yes, fine. Tag dot remove of index is missed. So that's why the found amount that have been not removed. Let's try it again. So if you see, we performed our stag as 10, 20, and 30. Okay, so we got it. Okay, let's perform the stag dot pop. Is it returning properly or not? So it returns some value. So just we can same this out. Uh, pop element in the stag. Let's run this. If you see, the stag is 40, and if I keep the same statement after this, so if you can see, stag is 20. So our simple stag is working absolutely fine. Now we perform the sum calculations. How? So what is the sum of these elements, and we will do that the calculations. So let's go here. um, so first what we have to do, we have to check um, whether array list is empty or not. Just we will add the first element over to the sum. So if um, let's go null sum. Okay, let's array of the sum. So let me correct it here. Okay, so if it is a null, let's if first element is null, just simply we will add this element to this. So dot add, okay, particularly element. So I have added the element. You can see that element is added over here. Okay, so let's if it is not null, what we have to do is we have to get the top element and then add it and push it back. Okay, else yeah, okay, else array list not. So okay, array list of sum. Okay, dot add. Okay, here what we have to do, get sum. So get sum, the existing sum we have to get max. We'll get some method. Okay, just sum, not get actually sum. Okay, plus element. Okay, just to perform the yearly element and store it simply. So some will be calculated over here. So just we have to go here and say what we have to say. We should say that array list dot sum dot is empty. Okay, question mark -1 colon. Just we pass the array is not empty. Okay, array is not empty. Okay, dot get index. Okay, simply we will pass that. So let's here why we need to pass sum might be a 0 1 -1. So okay, uh, this is a sum. We will calculate the average also. So for average, we have to do some simply uh, some dot get at least. whatever we get a sum divided by size. So already we have implemented the size over here. Okay, so we do the size divided by that. Get sum. Okay, so sum sum divided by size simple average. So just we will typecast it to the level. That's fine. Okay, this is done. Next, so we have added element. So we have added element and successfully. If we remove the element, that element should be subtracted. So we should say in the pop also we should write a logic stating that whenever we remove okay, so when should we remove the element? When index is greater than 0, we have to remove the element. Okay, we have to remove the element. Minus return or return values. Okay, so we say, and so here we have the element as arrays. So before removing it, right, so we have to perform array list of sum dot remove. So from here also we have to uh, remove that element sum minus. So here if we subtract, it will be fine actually. Remove that element. Okay, it will be fine. So if we remove that element, it will be fine for us. So we removed it. Okay, so just we will check the sum is working fine or not. Okay, just we will print here sum. So we got some elements in the stack. So just we keep some. So let's perform the sum. Save, run. We can still have errors. What is that error? Double cannot cast. Right? Integer is an integer. Okay. What if cast it to double? Not fine. Whatever it is. So sum of element is 100. That is correct. So let's remove. After the removing of this, what is the sum we need? Okay. So after removing of elements, what is the sum that we need to check? So 30 is absolutely correct. So let's check the average also. So average AVG. So just we call average method. Average. Just we quickly run it. So it's 15. Yep. Okay, fine. So let's implement the min for the last operation that we perform, min operations. So here we implement the min. So when we have the min operation, right? So what we do? So when we will check the array is min is empty. Okay. Array dot array list of min. Array list of min is empty. If it is empty, okay, is empty or it is having an element which is having an element okay, get min. So get min is less than the element. So we can do something like this, element or ELDM. Okay, just we will push the element into our, so, so just we will push element, else we push, else we have to push the, why this is over here, okay, so add, okay, that's missing, so same thing, but here we will push the get min, okay, right, okay, fine, so we are done with this, and same way we implement the max also, so max, so we check element is greater than get max, right, okay, element is greater than the max, so I will push the max, else I will push the element, that's correct, so we have done, so just we have to take care in this, so simply when we remove an element, simply we will remove from here also, right, array dot min dot remove, uh, remove index, that is correct, so for max also nicely, nicely max, if you remove dot remove, we remove the element from the indexes, so we will just remove it, and we can see, okay, we are done, so just we will call here itself, we just copy it, okay, so minimum, what is the get min element, get get min element, so we call it as a get min, so we get a get min element, okay, okay, here you can see, here also we are trying to get a get min, and we can also try to get min max, so max, so max, okay, so we just change the name, get max, get max, okay, so just we will run it, so when we run it, right, so we got an null pointer over the pushing back, so what is that we did wrong over here, element, okay, we have not implemented get min, I think, yes, we have not implemented the get min at all, so we will implement the get min, so we implement the get min very, so just we will, what we say, if it is a, we will write the same expression over here and say that it returns it if any element is less or something, so just we will change this array list, okay, array list of min, and get of array list of min, okay, so we return -1 here, so what we do, we return, so we return -1, so nothing is there, that's why we are not returning anything, so same thing over here, min max, okay, so this is what, just right click and run, we should see our code should be what should find, okay, it's done some error, okay, get max, get min, min was working fine and max went wrong, okay, the list of max, where is max, so we are not checking element is greater than, so here something we did wrong, okay, sorry for that, we copied and we did not, we copied but we did not change the logic over there, so now we can see the stack contains 10, 20 and 30 and top elements are 40, the sum of average is 100, the average of is 50 and min is 10, max is 40, Stack contains after the pop operations we see stack is 20 and 30 top elements 15 and min and max you got a 10 and 20. Okay, so this is what a simple stack example we have implemented the push and pop operations and top peak uh, getting of top element and min and max sum and average. Thanks for watching the stack problem solving. In the next session we will take up a small problem over the stack and uh, try to solve completely. Thank you so much. If you like it, like and subscribe for more videos. Thank you. Thank you. Bye.